everybody, we're back again with more exciting nomenclature for you. So this is Skills from First Year Chemistry 101, and this is nomenclature, and we're talking about ionic substances now. So this is part 2 of 3, I'll say.
Part 2 of 3?
Mm-hmm.
Oh yeah.
Okay, so ionic substances. Just keep in mind we have the big picture of 3 different kinds of substances. We have covalent, ionic, and acidic. So ionic substances, amazingly enough, I always say this, amazingly enough have ions in them. So they're made of ions. And an ion is just a charged atom or molecule. And generally, these will lead with a metal and finish with a non-metal or something called a polyatomic ion. And part of your summer assignment was to practice and learn and memorize all of those polyatomic ions. So I'm going to assume that you already know the formulas and charges for the polyatomic ions as I'm doing this lecture. So like I said, ionic substances are made up of generally a metal and a non-metal. They're charged particles and they're attracted to each other because of opposite charges. And that's what keeps the ions together. And that's a totally separate lecture that we'll talk about. Those are called Coulombic forces. So anyway, the nomenclature of ionic substances can be boiled down to this. If we do a name to a formula, if we're going this direction, if we're given a name and we want to go to the formula. So a name would be like sodium chloride, and a formula would be the symbols from the periodic table. If you're going from a name to a formula, your guiding principle for this is that charges must balance out. So that just means that they must add up to 0. And we'll talk about what that means a little bit more here when we do some examples. But you always want your ions, when you go from a name to a formula, to add up to 0 to make a neutral substance. Okay, and then when you're going from a formula to a name, you're going back this direction. You always name the cation first. That's the positive one. And then you name the anion second. And that's the negatively charged one. So you lead with the positive here, of course. You want to remember that. Okay, so going from a name to a formula, balance your charges, and going from a formula to a name, the cation gets named first and then the anion. And we'll do some different examples in which we have some easier ones and some more challenging ones. Everything okay?
Yeah.
Okay, good.
I think you nodded at me to go.
Okay. All right, so here's our example table. We're going to do name and formula. And we'll just do a name to a formula and then a formula to a name, and exercise these guiding principles to transfer between them. Okay, so let's say, for example, that we have a name like sodium carbonate. So your first thing that you want to do when you are writing a formula for a substance is look up the players involved. Look up the charge on each one and the formula, and then you can work out how many of each one you have to have in order to make a neutral substance. So you would look up on your ion table and you would find that sodium has a +1 charge and carbonate has a -2 charge, has the formula CO3 -2. So what we want to do is figure out what formula is going to give us a neutral substance, meaning how can I make those charges add up to 0? And since we have a +1 here and a -2 here, we need 2 of the sodiums for every 1 of the carbonates. So when we write the formula for that, we would put a 2 after the sodium, and then we would write the formula for carbonate. So it would be Na2CO3 for sodium carbonate. Okay, and so another example, let's say that we have, we'll do potassium sulfide. And we want to get from the name to the formula. We're given the words and we want the formula. And of course then we're going to look up our players involved. Potassium is +1 and sulfide is -2. So this is a similar situation, but in this case we have a monatomic ion versus a polyatomic ion. So the formula for this guy, we're going to use 2 potassiums and 1 sulfide. So we'd have K2S as our formula. We used 2 potassiums because they're +1 each, and 1 sulfide at -2, and to balance it out is K2S. Okay, so let's try another one. Let's say that we have CuNO3 2. And so we are at the formula this time, and we want to go to the name. And so what we're going to do is follow our guiding principle here, and that is to name the cation first, and then to name the anion. So we want to hone in on who's the cation and who's the anion. And the cation is always going to be your first ion. And so in this case, it's copper. And copper is one of the elements that can have more than one charge. So what we have to do is figure out what the charge is based on who copper's with. And so what we're going to do is just say, all right, this is copper. We know it's copper. And we're going to put some open parentheses right after the word copper so that we can put in the copper's charge. And so we're going to figure that out here in just a second. And so we know it's copper, and then we look over here and see this polyatomic ion NO3, and that's nitrate. So it's copper something nitrate. Now, I can tell you that the charge on a nitrate is -1. There are 2 of them. So this copper, in order for this whole substance to be neutral, this has to be copper 2, copper +2. So we would say copper 2 nitrate, just like that. Okay, and then we'll do one last one where we're given, maybe we'll do 2 more. We're given a formula of, we'll give a name this time. We'll do magnesium hydroxide. So this is an example where we're working with a +2 charge on the magnesium. We have Mg +2, and then hydroxide is the polyatomic ion OH -1. And so what we have to do is figure out what number of each ion do we need to make a neutral substance. Since we have +2 here and -1 here, we're going to need 2 hydroxides to every 1 magnesium. So our formula is going to look like this: Mg, and then we put into parentheses any polyatomic ion that we're using more than one of. The parentheses go around it, and then you put on the outside of the parentheses the number of polyatomic ions that you needed to use for that situation. So the formula for magnesium hydroxide would be MgOH2. Okay, let's do one last one that might be a little bit more challenging. We're going to do ammonium phosphate. Okay, so this is an example of a situation that we have all nonmetals, and so we would be tempted to name this as a covalent substance, but we have to recognize that the ammonium is a polyatomic ion. So, therefore, the substance is ionic. So again, we're just going to look up our players, and we're going to see that we have ammonium is NH4 plus 1, and then phosphate is PO4 negative 3. So this guy's charge is plus 1, this guy's charge is negative 3. So in order for us to balance them out to 0, what we're going to do is use 3 of these to every one of these. So we're going to put into parentheses this whole big monster here, NH4, and we're going to use 3 of them, and then PO4, just 1. So that's ammonium phosphate. Okay, I think that's it for that particular topic, and we will be back with some acidic nomenclature following this break.
With part 3.